Synthetic Genomics is a company founded by J. Craig Venter, most famous for sequencing the human genome, and also for creating what he calls the first synthetic organism. In order to use synthetic biology, that is, man-made life, to attack problems such as the need for replacements for petroleum-based fuels, cheaper ways of producing drugs, and other needs that can be approached literally by rewriting life. Here's a tour.
This is our what we like to call our algal treadmill. And so what we're doing here is an advanced evolution experiment. We take our natural algal strains, we put them in this turbidostat or photobioreactor, and we basically put them on almost like a treadmill. So we accelerate the dilution rate, and only the guys who are fat enough and fit enough to keep going within this vessel will proliferate. The guys who are slow or unfit will be washed away. We know that natural strains do not do this phenomenon that we're looking for. And we're trying to evolve Mother Nature to actually do that, to make the biofuel that we want at the speed we want. So when we grow biofuels or algal biofuels outdoors, they're open to the environment and they see a solar day. So this apparatus here is to basically mimic a scaled-down model of an outdoor pond or raceway, algal raceway. And so you can see here that the algae is growing. We'll be taking samples, measuring how much light is going into the sample, how much biomass the sample is making or the algae is making, and also how much biofuel product it makes on a daily basis. And what we're doing here is basically changing the way that people in the laboratories synthesize DNA. This machine is capable of making 32 genes within 15 hours, which would take you a team of 4 or 5 researchers to do in a conventional laboratory. So a researcher can basically order DNA online, send it to our facility here in La Jolla, where the design and ordering of the oligonucleotides will be sent to a third party. From that point, the researcher then receives the plate of oligonucleotides. They put it in this machine. There's an algorithm beamed to the machine, and a set of instructions are beamed to that machine, which allow it to synthesize whatever design DNA the researcher desires. So you can imagine that an experiment that we've devised from the BioXP or the DNA printer next door, we basically want to put into this new strain. And if this was E. coli, it would take us about a 3-day process to do so. Now the technology that Matt has developed here gets all this done within 1 working day. So here you can see a comparative experiment between our favorite strain, which we call Vmax, and conventional E. coli. So this experiment will start exactly the same day. And you can see within a very short time frame, you have a lot more cellular biomass on the plate than conventional E. coli.